Hello. Uh, yes, we welcome you back to PSSB with me, Richard here. And today we are looking at this question. It says that consider the two forces acting on a rock as shown below. So this is the rock we are having. This is the sketch, the rock, the two forces. And the question says, sketch the tail-to-head vector diagram showing F1, F2, and the resultant force, and indicate the angle between F1 and F2. Okay, so how do you go about this one? You have to know that what we call a tail-to-head is that this head of this vector must be in touch with the tail of this vector. I need to remind you that what you have here, where the arrow is the head, and what you have behind that is the tail. The same applies here. So this is the head, this is the tail. So when we say tail to head, the tail must be in contact with the head. And how do you go about this? If you have this one as our F1, then our F2, its tail must be in contact with this head. So what do? We bring it here and we draw it like this. Yeah. So this is what we call tail to head. And the distance from here, from the head of our F2 to the tail of our F1 is what we call the resultant, or the resultant force. Okay, I need to remind you that a vector remains the same provided it has the same magnitude and same direction. That is true irrespective of its point of origin. So in other words, shifting F2 to here does not make it different. It remains F2. So what are we going to do? What we are going to do is to draw our resultant like that. And now we need to know the direction of the resultant. The direction of the resultant is in this direction where these two are aligned. So in other words, our resultant is that. Okay. Yeah, that is it. Then we come to the second part where they say indicate the angle between F1 and F2. How do you go about that one? Here we need to practice some geometry, just that. If you draw a line here, a vertical line, and you also continue with this line, you are going to discover that this angle here is the same as what we had there. So it is 50 degrees Celsius. You need to know that from this x-axis to the y-axis, the angle is 90. That implies that this angle here is 40, because these two must make up 90. And you need also to recall that the angle here is 90 degrees, because it's between horizontal and vertical. Knowing that, and they wanted us to calculate the angle between F1 and F2, what is it? It's the sum of these two. So if this angle is designated theta, our theta is going to be 40 degrees plus 90 degrees, giving you 130 degrees. Yeah, then we come to this case. It says that two forces are applied on the glass slab as shown below. So this is the glass slab, and these are the two forces. And the question says that draw the tail to head vector diagram showing F1, F2, and the resultant force Fr. Okay, how do we go about that? Okay, this is what you have to know, that what we call tail to head is that the head of one force must be in contact with the tail of the other one. I need to remind you that for a force like this one, this is the head and this is the tail. Yeah, if we maintain the horizontal one, which is this one, which is the 8 Newton force, then where does this one come? It comes, its tail must meet this head, so it comes here, like that. You have to remember that they must not change the direction. So after that, let's make this one a bit shorter to be relative. After that, what do? We draw the resultant. The resultant must be between this head and this tail, and that is it. Now next we find direction of the resultant. It must be in the same direction as these two, so that is that. Yeah, this is the tail to vector diagram showing the F1, the F2, and the resultant. Yeah, then we come to this question. It says that calculate the resultant force Fr. Yes, how do you go about this? Here, you need to recall our vector diagram. It was like this and like that, and then this one was our Fr. Okay, now what are we determining? Suppose we call this one F1 and this one F2. So we're determining the resultant force, and here we apply a mathematical principle which has been in existence for years. We call it Pythagoras theory. It says that when you have two vectors at right angle to each other, then the resultant vector and the F1 and F2 are given by this relationship, which says that F resultant squared is equal to F1 squared plus F2 squared. Yeah, that is Pythagoras. And what do we do here? We do the substitution. If F1 is the one 80, so it's going to be 80 squared plus 64 squared, giving us Fr squared. From here, what do? We perform the calculations. Yeah, that's what we get. And when you add the two values, we get, yeah, that's what we get, which is 10,496. From here, what do we do? We find the square root of both sides, so it's going to be FR squared, and we'll have its square root, which is equal to this one, and we'll find the square root. You have to recall that what we are finding is FR, not FR squared. So from here, what we get, we have the resultant force, which we get as, yeah, and that is that. So this is what we get as our resultant force. And with that, I would like to thank you for your time. The channel is PSSB, Physical Sciences, Silver Bullet with me, Richard here. Yes, we urge you to subscribe, to comment, to like, to share. Yes, we believe we are simply the best. See you next time. Bye-bye.